this lesson, we're going to talk about finding intercepts. And we're going to do that from a graph, from a table, and from a function. So this is something you can always refer back to kind of give you some tips as we're going through this. Some of the vocabulary pieces you're going to need to know is your ordered pair. We've talked about this before. It's the address of a point. You have the x-coordinate and the y-coordinate. We always write our point as x, comma, y. Okay? And then we have the intercepts, which when you're talking about an x-intercept is when a function crosses the x-axis, and when you're talking about a y-intercept, it's where the function crosses the y-axis. So let's jump right in. Let's start with a graph. Okay, we're going to find what are our x-intercepts and our y-intercepts. So let's start with the x-intercepts. Okay, so the first thing you need to do is know where your x-axis is. So remember, your x-axis is always your horizontal axis. So it's this one right here. So we're looking for where our graph function crosses that line. And there's two places where this one crosses, right here and right here. So then we just have to write the ordered pairs for those intercepts. So this first one right here would be the point -5, 0, because we went over 5 spaces to the left, so that's negative, and up 0 spaces. The second point right here would be, let's see, we're just going over 1, so that's a -1, and then of course 0. X-intercepts should always have 0 for the y-coordinate. And then it's opposite for a y-intercept. For a y-intercept, we're trying to cross, or trying to find where the function crosses the vertical axis. Okay? So your x-coordinate for that should always be 0. So I know that my y-intercept will start with 0. And then I just find where it crosses that axis. So this one goes down 1, 2, 3, 4, 5, 6. I believe it crosses right there. So we're going down 6, so that's a -6. And that's it. We're just identifying those points. Okay, so let's try the next example with the graph. First of all, looking at this, here's my x-axis. How many x-intercepts do you see? 1, 2, 3. So then we just have to identify those points. Separate this for us. Our x-intercepts would be, if I'm looking for this point right there, I'm going over 1, 2, 3, 4, 5, 6, 7, 8 to the negative. So I'm going -8, and what's my y-coordinate? Always 0 when you're talking about an x-intercept. We also have this point right here. So that's over 1, 2, 3, 4, 5. So that's a -5, 0. And then our final point, way over this way, is, let's see, if this is 5, then we have 6, 7 in the positive direction. So it's 7, 0. Great, let's find our y-intercept. So I'm going to get all this off our picture for us. And so our y-intercept, remember, is where the line crosses that vertical axis. How many y-intercepts do you see? Just one, right here. So y-intercepts, remember, what is always our x-coordinate? If we were looking for that ordered pair, right here, we would say it is 0 and then up 1, 2, 3, 4. So that's my y-intercept. And so if you look, let me grab my highlighter here. For our x-intercept, look what is always your y coordinate. For an x-intercept, y is always 0. And then that's opposite when you're looking at your y-intercept. For your y-intercept, your x-coordinate is always 0. Also, notice that while we have multiple intercepts, when we're talking about x-intercepts, how many do we always have for a y-intercept? Just one. If it is truly a function, you should only ever have one y-intercept. You could have as many x-intercepts as you want. Doesn't matter. You don't even have to have an x-intercept. But you should always have one y-intercept, or almost always have one y-intercept. All right, so let's talk about from a table. So remember I said that when we're talking about an x-intercept, y is always going to equal 0. So when we're looking at a table to find our x-intercepts, okay, we want to look at the y column and find where it's 0. So I see a 0 here, and I see 0 here. What is the x-intercept? We'd have the point -2, 0 and the point 1, 0. So we have two x-intercepts. But remember, I said for a y-intercept, what is always 0? This time x is always 0 when we're looking for a y-intercept. So where do you see x is 0? Right here. So what's my y-intercept? It's 1. The point 0, 1. Great. Looking at the next one, how many x-intercepts do you see? Remember that to be an x-intercept, y has to equal 0. So we should be looking down the y column, and I have 1, 2, 3 zeros. So that means my x-intercepts would be -3, 0, -1, 0, and 3, 0. How many y-intercepts do you see? Remember, to be a y-intercept, you're looking for where x is 0. I only have one place where x is 0. That's the point 0, 2. So this would be my y-intercept. The rest of these were x-intercepts. Okay, let's try the next one. How many x-intercepts do you see? One last reminder that x-intercepts mean that y is 0. So that would mean I'm looking down the y column to find 0. This time I only see 1. So this point right here, 1, 0, is going to be your x-intercept. What is my y-intercept? Remember, for a y-intercept, we want to look for where x is 0. So that would be this point right here. That is my y-intercept. Okay, try the last one. We'll start by finding our x-intercepts, which means we want to look for where y is 0. So if I'm looking for where y is 0, that means I have a x-intercept here and an x-intercept here. I'm just going to mark that as x. I'm running out of space. Then let's look for our y-intercepts. Remember that y-intercepts mean that x is 0. So I'm going to look down the x column for where x is 0. So that means this point is my y-intercept. Not too hard, right? You just have to remember, when you're looking for an intercept, it's the opposite coordinate that equals 0. So an x-intercept is y is 0, a y-intercept means x is 0. So let's look at how to calculate that using the function. And feel free to use a calculator to help you with this. We're going to find, for right now, just the y-intercepts. Okay? So remember that the value of x when you're looking for the y-intercept is 0. So we're just going to plug in 0 anytime we see x and then solve. So here's an x, we're going to plug in 0. Do you remember from lesson 2.1b what these bars mean? They're absolute value. Absolute value means that the number inside of it will become positive. So if we simplify, we have 0 minus 6 is a negative 6, but this is absolute value, which is the distance from 0. So how many spaces away from 0 is negative 6? It's 6 spaces. So we end up with now 6 minus 9, which will become a negative 3. So our x-coordinate was what? 0. And my y-coordinate is negative 3. Let's just scoot some of this over to give us some more space. Whoa, not that. All right, let's look at problem B. Again, what am I plugging in for x? I'm plugging in 0. So I'm going to say y equals the square root of 0 plus 25 and then minus 1. So 0 plus 25 is just 25. Square root of 25 is 5. So the y-coordinate will be 4. And what is always my x-coordinate? 0. Cool, let's try the next one. What am I plugging in for x? 0. So y equals 2 times 0 minus 7. We start by simplifying the multiplication. 2 times 0 is 0. And 0 minus 7 is negative 7. What is my x-coordinate? So my y-intercept is 0, negative 7. Let's try one more before I have you try one on your own. What am I plugging in for x? So I'm saying 0 squared minus 5 times 0 plus 2. What is 0 squared? 0. What's 5 times 0? 0. What's 0 minus 0 plus 2? So what does the coordinate look like? The x-coordinate is always 0, and then we just found that y is 2. Wonderful. This last one you're probably going to want to use a calculator for. We haven't talked about exponent rules yet. So, what am I plugging in for this x? We're plugging in 0. And what is anything to the 0 power? It's 1. So what does my coordinate look like? X-coordinate is always 0, and we just found the y-coordinate to be 1. And that's how you find a y-intercept from an equation. So we've talked about how to find both the x and y-intercepts from a graph and from a table, and now we have figured out how to solve for the y-intercepts. Go ahead and try your practice problems.